What's going on, everybody? This video here is derivative of logarithmic functions. So let's go ahead and get started. So I've got the derivative of log u with base b is equal to 1 over u times the log of e with base b times the derivative of what you're taking the log of. And then the derivative of natural log u, now this one's easy to do. Notice I've got natural log. That's going to be whatever you're taking the natural log of, that goes in the denominator, and then the derivative of that goes in the numerator. That's all that means. Now, let me talk about this one just a little bit. The book that I'm using, okay, the book that I teach out of, uses this for the derivative of log u base b. Okay. Now, a lot of calculus books are going to do it like this. They're going to write the derivative like this. Okay. Now, this is the same thing as this. What they're doing with this problem, with using this formula, is they're rewriting this. So if you remember, if you watched the last video, log of e with base b. So you remember that change of base formula? It's the last example in the video right before this one. This can be written as natural log e over natural log b. And then this natural log e, that's equal to 1. And this is over natural log b. And so that's where the 1 over natural log b comes from. So they're just taking this and they're replacing it with this, but it's the same thing. Okay? So, I mean, I've got one example to do, which is this one right here, where we are just using this formula up here. And what I'll do for this one problem, because all the rest of the problems are all natural log, and that's what you're going to come across mostly. Mostly what you're going to see when you're doing derivatives of logarithms is it's going to be natural log. Now, I'm not saying you're never going to come across log base e, where the base is, you know, a 2, a 10, a 5, or whatever. I'm not saying you're never going to come across that, but the majority of the time it's just going to be natural log. So for this first example, I will work at using both forms of the answer. Okay, so for those of you that are in my class, and you know, this is how the book does it that we use, and for those of you that use a different book and their formulas like this, you'll have that also. If you're in my class, I don't care which way you do it. It's up to you, because they're both correct. All right. So here we've got y prime is, all right, so let's look at this. Remember, it's 1 over whatever you're taking the log of. So that's going to be 1 over 4x. All right. And then it's going to be times the log of e with base b. So that's times the log of e with base 3. Okay, our base is 3 in this problem. And then it's times the derivative of what you're taking the log of. So times the derivative of 4x, so times 4. And so I get y prime is 1 over x times the log of e with base 3. And this is your answer. See, the 4, this 4 and this 4 cancel. All right. So now let's do it again. We've got y prime. All right, so that's the formula that my book uses. So if you're in a different calculus book, if they use the other formula, this is how you would do it. I mean, it's the same thing. You've just got to remember the formulas. So we're going to use this one now. So it's 1 over, well, and let me say this right here, this x, I should have written it more consistent with this, but that should be a u. It's 1 over u, okay? It's 1 over whatever you're taking the log of. So that's going to be 4x, and then times the natural log of b times the natural log of the base. So that's going to be natural log 3 times the derivative of what you're taking the log of. So times the derivative of 4x is 4. And so this is going to be y prime. The 4's cancel. That's 1 over x natural log 3. Okay. So either one of these answers are correct. Whichever formula you want to use, that's fine. Okay. Just pick which one that you like better and use that. Okay. But like I said, as you go through calculus, you're not going to encounter log of like this. You're not going to encounter it that often. Mostly it's going to be like this, natural log. That's why the rest of the examples are all natural log. All right. So let's continue on. All right, so remember, when I take the derivative of natural log, whatever you're taking the natural log of, that goes in the denominator, and then the derivative of it goes in the numerator. It's really pretty easy. So let's look at this. We've got y prime is equal to, now whatever you're taking the natural log of, that goes in the denominator. And then the derivative of this goes in the numerator. So what's the derivative of that? It's 12x cubed. And so if we reduce it, we get 4 over x. And there's your derivative. And yes, it is that simple. It blows my mind when students miss these problems because they're really easy. All you gotta remember is whatever you're taking the natural log of, that goes in the denominator. The derivative of that goes in the numerator. So let's come over here. We've got y prime is equal to, now what are we taking the natural log of? Tangent 4x. And what goes in the numerator? The derivative of that. Secant squared 4x, remember? Derivative of tangent is secant squared times the derivative of what you're taking the tangent of, which is the derivative of 4x is 4. So this is tangent 4x, and up here in the numerator is the derivative of tangent 4x. And so what is this gonna give us? Well, we can see about, trying to simplify this a little more. Let's see. We can write this as y prime, and that we could write that as 4, I don't know, secant squared 4x, cotangent 4x. You see that? Remember, this tangent down here, that's the same thing as 1 over tangent. What's 1 over tangent? Cotangent. And then I don't know why I put a y prime there. And so then we can rewrite this 4 times, what is that? 1 over cosine squared 4x. And this would be what? Cosine 4x over sine 4x. And then, see, one of these is going to cancel. And I'm left with 4 times 1 over cosine 4x times 1 over sine 4x. And so this is going to give me 4 times secant 4x cosecant 4x. Now, is that the best answer to give? Is that the best way to write it? I don't know. It's, is it better than leaving it like this as a fraction? I think so. Is it better than leaving it like this? Well, I mean, think about it this way. You got the squared here. This takes the square out. Honestly, I think this is a good way to do it. This is a good way to leave it also. Maybe put the 4 up here, or, maybe write this as 4 over cosine 4 over cosine 4x. sine 4x. You know, I would maybe something like that if you weren't going to do this. The reason I say this is because we've got sine and cosine buttons on our calculator. We don't have secant and cosecant buttons. Okay, so how would you write this final answer? Well, it'd probably be up to your teacher. If you're in my class, I would like to see it either like this or like this. Okay. All right. So moving right along. All right, so let's look at this one. So we've got y prime is equal to, now remember, whatever you're taking the natural log of, that goes in the denominator. And then what goes in the numerator? The derivative of this. Now, we're gonna work this problem like this. This is probably not how I would work it, but this is how we're gonna work this one. And then once we work the last problem, we're gonna come back to this problem and work it a different way. And I'm gonna let you see the difference. Okay, so here we put this goes in the denominator. Now I got to do the derivative of this for the numerator. So to take the derivative of this, I've got to use quotient rule. So it's the derivative of the numerator times the denominator minus the derivative of the denominator, which is 1 times the numerator, over the denominator squared. All right. And so this is going to give me y prime is x plus 1 minus x plus 1. I just cleared the parentheses, over x plus 1 squared over x minus 1 over x plus 1. And so this is going to be y prime. The x's go out. I've got 2 over x plus 1 squared over x minus 1 over x plus 1. Now let's write this a little better. So that's going to be y prime is 2 over x plus 1 squared divided by this, or what? Times the reciprocal. Remember that? Times the reciprocal. So this is going to cancel out with one of those, and so I'm left with y prime is 2 over x plus 1 times x minus 1. And this would be your derivative. All right. So that one, it was a little more involved to simplify it. Okay, that's all it was. But the procedure was the same. What did we do? Whatever we're taking the natural log of, that goes in the denominator, and the derivative of this goes in the numerator. All right. So we're going to actually come back to this problem, and we're going to work it again. So let's write it over here again. Whoop. Some of you may know what we're going to do, and some of you may not, but we will come back to it. All right. All right. So let's go to this one. All right. So this is going to be y prime equals, now remember, whatever you're taking the natural log of, that goes in the denominator. So 1 minus 2x cubed, that goes in the denominator. What goes in the numerator? The derivative of this. And so that's going to be 3 times 1 minus 2x squared. 3 comes down, subtract 1 from the exponent, and then times the derivative of what's inside the parentheses. So the derivative of 1 minus 2x is negative 2. And so you can see these cancel, and so I get y prime is equal to negative 6 over 1 minus 2x. And there's your answer for to that one. All right. And I tell you, we may come back and do something else with this one too. We'll try something different on that one too. Now as far as this one goes, it's not going to make that much difference on this one, but you'll see what I'm talking about when we go back. All right, so this one right here, don't get it confused with this one. I mean, it looks like the same problem, but notice where the exponent is here. Notice where the exponent is here. If you remember and you watch the video when we were doing derivatives of the sine and cosine, the trig functions, well, this is similar. This is y equals the natural log of 1 minus 2x. And this cubed here just means all of that is in parentheses raised to the third power. Okay, so we've got chain rule here. So we've got y prime. The 3 comes down. 3 natural log 1 minus 2x. And remember, we subtract 1 from the exponent. That's squared. Okay. And then with the chain rule, the 3 comes down, subtract 1 from the exponent. And then it's times the derivative of what's inside the parentheses. So now we got to multiply times the derivative of this. So what's the derivative of this? Well, we're taking the derivative of a natural log function. So the 1 minus 2x goes in the denominator, and then the derivative of this goes in the numerator. Okay, so it's times that. And so I get y prime is going to be, let's see, how do we want to write this? How about negative 6 natural log squared 1 minus 2x over 1 minus 2x. And there's your answer. Okay, so on that one we did have to use the chain rule. Okay. Now, you know, if you watched my other video when we were doing the trig functions, you don't have to put the parentheses cubed. You can leave it like this. I'm just doing it like this so that you can actually see it's in parentheses raised to that power. Okay. All right, so this one, evaluate the derivative of this when x is 0.375. All right, so let's write the problem down. So we've got natural log of sine 2x times the square root of x squared plus 1. All right. Now, if you're taking notes, okay, if you're taking notes, don't write this down. I want to show you this. So remember, if you take the derivative, whatever you're taking the natural log of, that goes in the denominator. And then what goes in the numerator? The derivative of this, right? We would have to do product rule. So once again, don't write this. Derivative of sine is cosine 2x times the derivative of what you're taking the sine of. That's the derivative of the first function times the second function plus, and then derivative of the second function. Remember, the derivative of square root is that's going to be that. That's the shortcut. If you've been watching the videos, you know how to do the shortcut. It's just 2 times whatever the square root is. That goes in the denominator. And then the derivative of what's under the square root goes in the numerator. And then that would be times the first function, sine 2x. And then, after you do that, now you have the pleasure of simplifying that. Now, that's not going to be very fun, is it? That's not going to be fun at all to try to simplify that thing. So we don't want to work it like that. That's not what we want to do. All right, so let's erase that. So if you remember back when you took algebra, most of you, not all of you, but most of you probably hated the section on logarithms, expanding and condensing logarithms and all that stuff. Well, let's look at that. Can't we rewrite this as the natural log of sine 2x plus the natural log of this, plus the natural log of x squared plus 1 to the 1, the square root of x squared plus 1, but I'm going to write the square root as a 1/2 exponent. Okay? So remember, multiplication we can split up using division. I'm sorry. We can split up using multiplication. I'm going to get it right here in a minute. If you've got multiplication, you can split it up using addition. Okay? That was a big blooper for the video, wasn't it? I'm not going to take it out though. So anyway, so y equals the natural log of sine 2x plus, now remember we can take this 1/2 and bring it down in front. Now let's take the derivative. Isn't that much easier? So we get y prime is equal to, so what is this? Sine 2x, whatever you're taking the natural log of, that goes in the denominator. Derivative of this goes in the numerator. So the derivative of sine is cosine times the derivative of what you're taking the sine of. The derivative of 2x is 2. And then plus 1/2. And then remember, whatever you're taking the natural log of, that goes in the denominator. And then the derivative of this goes in the numerator. And so we've got y prime is 2, and that's going to be cotangent 2x. And yes, if you're in my class, I want you to rewrite it as cotangent. And then that's going to be plus, and then look, the 2's cancel. That's going to be x over x squared plus 1. And there is the answer for that one. Well, I'm sorry. No, it's not the answer for that one. So they want us to plug 0.375 in. So y prime of 0.375 is going to be 2 times cotangent of 2 times, let's see, 2 times 0.375 plus 0.375 over 0.375 squared plus 1. And after you plug all of that into your calculator, you end up getting 2.48. Now, if you're watching the video, you got your calculator pulled out and you're plugging all this in. You say, well, I'm not getting the right answer. Well, just remember, whenever you're doing this one, remember your calculator has to be in radians. Okay? So make sure it's in radians for the trig function. Yeah, and then just plug it in, just take your time. Okay, like I said in previous videos, I can't show you how to plug it in with the calculator because I don't have a calculator on the screen here. So let's come back to this problem as promised. Okay, so if you forgot about that, you might have thought the video was going to be over, but it's not. We got to come back and do this one. So remember, we worked this problem and we had to do all that work there. Okay, well, let's look at it. Y equals, now look at this, x minus 1 minus natural log x plus 1. You see the division? I can split that up using subtraction, just like we did in that last problem we worked. And so I got y prime, whatever you're taking the natural log of, that goes in the denominator. Derivative of this is 1, that goes in the numerator. Same thing here, the x plus 1 goes in the denominator. Derivative of this, which is 1, that goes in the numerator, and there's your answer. Isn't that nice? Okay, you like logarithms now, don't you? I bet you do. All right, and yes, it's the same answer as this. Look, if we took this just real quick and got a common denominator, all right, that's x minus 1. We got to multiply by x plus 1, so we got to multiply the numerator. Got to multiply the numerator by x minus 1 there. And look at this, x minus x is 0. 1 minus negative 1 is 2 over x plus 1 times x minus 1. See, it's the same answer, but this was much easier. Okay. How do I want the answer if you're in my class? I mean, I'm happy with this. I'm happy if you get it right. Okay? You can leave it like that if you want. And if you want to get a little more dangerous about it, go ahead and combine them into one. Okay? And then the same thing here. Now, it's not, I don't think it's going to make that much of a difference here. But look, if we had y equals natural log 1 minus 2x cubed, look at this. y equals 3 natural log 1 minus 2x. I can take the exponent and bring it down in front. So what is that actually doing for me? Well, it's saving me from having to do the chain rule up top. So this is going to be 3, and then I've got the 1 minus 2x. That's in the denominator. Derivative of this is negative 2, and so I get y prime 3 times negative 2, negative 6 over 1 minus 2x. So you can see that with the logarithms on some of them, you know, if you've got like that when we had a fraction up here, down here we would have had to have used the product rule to do the numerator when we took the derivative. But you can see by expanding the logarithms, it makes the problems easier to work. Okay, but the main thing in this video is taking the derivative of logarithms. And like I said, most of the time it's going to be doing the derivative of natural log. Okay, and all you have to remember to take the derivative of a natural log, whatever you're taking the natural log of, that goes in the denominator, and then the derivative of that goes in the numerator. That's all there is to it. All right, so I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. I'll see you in the next one. Later, and thanks for watching.